Hello everyone, I am Siddharthan. Welcome to my YouTube channel. This is the 8th project video in our hands-on machine learning course with Python. In this video, we are going to see how we can build a car price prediction system using machine learning with Python. Okay, so first of all, let's try to understand more about the dataset we have and what we are going to do about this. So the problem statement is that we have to predict the car prices of used cars. Okay, so we have several information about those used cars, and this particular data set contains car brand. So what is the brand of the car, and what is the year of that particular model, and at what price that particular car is sold, and the present price of that car, and the kilometers driven, fuel type, whether it runs on petrol, diesel, or compressed natural gas, those kind of things. Seller type, whether the seller is an individual or a dealer. Then the transmission, whether the gear system is automatic or manual, and then the number of owners of that particular car. So these are the data set features. So using these using these features in the dataset, we need to train our machine learning algorithm that can find patterns in the dataset. So once we give new information, it can predict at what price that particular used car can be sold. So this is our problem statement. Okay. So I hope you have understood what we are going to do. Now let me explain you the workflow we have for this particular project. First is data collection. So we need this car data. So the data set which I have shown you. Okay. So we need this data to feed this to our machine learning model. Okay. So I will be telling you where you can get this data set and what are the various aspects present in this particular data set. So once we have this car data set, so we need to pre-process the data. Okay, so we cannot feed this raw data to our machine learning algorithm. So for it to understand the data, so we need to do some processing. So this step is called as data pre-processing. Okay, so once we process the data, we will split this data into training data and testing data. Okay, so this step is called as train test split. Okay, so once we have splitted this data, we will train our machine learning algorithm with training data, and we will test or evaluate our machine learning model with this test data. Okay, so we will feed this to our regression model. Okay, so in this case we are going to use two regression models. So first we will train our machine learning model with the linear regression, and then we will use the lasso regression model, and we will compare the accuracy score or the error percentage of these models and see which model performs better for this particular data set. Okay, so this is a regression example. So the previous videos which we have seen are basically classification problems. So in the case of classification problems, we will predict into which class the particular data type belongs. Say for example, we have made a project on diabetes prediction. So in that case, our machine learning model will predict whether a person has diabetes or not. So it is like class. It just predicts it's yes or no, or it's zero or one. Those kind of problems are known as classification problems. This is a regression problem because we are predicting a particular value. Okay, so we are not just predicting classes. We are just predicting particular value on which the car can be sold. So this is known as regression problems. So we will be using linear regression, and then we will be using our lasso regression and compare it. Okay, so once we have trained our model with this regression model with this training data, we will evaluate our model. Then we will have a trained linear regression or lasso regression model. Then we will feed new data to our machine learning model. So on understanding this data, or on operating on this data, our machine learning can predict the car price on which it can be sold. Okay, so now let's get into the coding part of it. So before getting started with the coding part, I'll just give you a short walkthrough on my YouTube channel. So in my channel, I'm making a hands-on machine learning course with Python. So you can see the course curriculum video here. So in this video, I've explained what are the different modules and videos that I will be posting in this video in future. So you can download the course curriculum from here. So it contains various modules and topics which I will be making. So I will be posting videos on Monday evening and Wednesday evening, and every Friday evening I will be posting a machine learning project video. Okay, so you can go to this playlist option here. So here you can see various modules in my course. So the first module is machine learning basics module. So and the second module is Python basics module. So if you are new to machine learning, you can start watching from this module. And the third is important Python libraries, where I will be explaining about NumPy, Pandas, and the other libraries. So I will be posting the remaining videos for these modules on Monday and Wednesday evening. And as I've told you earlier, Friday there will be a machine learning project video. So you can go to this machine learning project playlist. So you can see here. So totally there will be uh, 8 project videos, including the one that I am recording. Okay, so you can watch all these project videos. Okay, so this is about my channel. So do subscribe and stay connected for future videos. Okay, so now let's get started with today's topic. So this is car price prediction. So this environment is called as Google Collaboratory. So Google Collaboratory is very useful for running Python programs. Okay. So if you are new to Google Collaboratory, or if you haven't heard about it, you can check out my Google Collaboratory basics video. So it will be in the module 2. So the name of the video is Google Collaboratory Basics. So the index of that video is 2.1. Okay. So you can find that in my channel. So now let's get into this. You can see here I have already uploaded this card dataset. Okay, so you can download this dataset. I'll give the link of this file in the description of this video. So once you have downloaded it, so you need to upload it to this Google Collaboratory environment. Okay, so you can go to this option, so upload to session storage. Now you can upload this dataset file. Okay, now let's get started with the code. The first step is to import the dependencies. Okay, so once you have opened your Google Collaboratory, you need to connect your system from here. Okay, so first step is importing the dependencies. Okay, so you can press shift plus enter to run this cell and go to the next cell. Okay, so first of all, let's import pandas. So import pandas as pd. Okay, so next let's import matplotlib matplotlib.pyplot as plt, and then let's import Seaborn as SNS. So pandas is basically used to make data frames. So data frames are more structured tabular forms. So we cannot. So the data set we have is a comma separated value. So when we feed this to this data frame, it is more easier to analyze and do some processing on the data set. So that's why we are using this pandas library, and this matplotlib library and Seaborn library are very useful for making plots. So then let's import from sklearn dot model selection. Let's import train test split. So as I've told you earlier, so we need to split our original data into training data and test data. Okay, so this function is useful for that. Now let's import our linear regression model. So from sklearn dot linear model import linear regression. Okay, so first we will train our data with this linear regression model, then we will train it with Lasso regression. Okay, so these two are one of the most important important regression models in machine learning. So from sklearn dot linear model, let's import Lasso. Okay, now let's import from sklearn import metrics. So this metrics module is used to evaluate our model, okay, to find the error score, accuracies, etc. So metrics. So you can run this by pressing shift plus enter. Okay, so this will load all the libraries and the functions we need. So as we have done that, next we need to collect our data. So this data is collected from Kaggle. So you can just search car price dataset Kaggle. So you will be shown the pages of Kaggle in Google. So from Kaggle you can download this data. Okay, so I'll also give the link for it. So this step is data collection and processing. So I'll make a text here, data collection and processing. Okay, so now we need to load our CSV file. So as you know, we have the data in a CSV file, right? Now we need to load this data present in the CSV file to a pandas data frame. As I've told you earlier, pandas is a tabular form, and if we load that to this tables, it is very easy to analyze and process the data. Okay, so we are going to just copy this path. So you can copy the path from here. Okay, now loading the data from CSV file to pandas data frame. Okay, so I'll declare a variable called as car dataset. So this will be the name of my data frame. So we have this car dataset. So you need to use the function pd.readCSV. Okay, so in this parenthesis you need to copy and paste the path that we have copied. Okay, so as you can see here, I am using this pandas library. So you can see here that I have imported pandas in the short form as pd. So this pandas has a function read csv. So using this function we will be loading our csv file to a data frame. Okay, so I'll run this will load our data. Now let's check the first 5 rows of our data frame. Let's check the sample of this data frame. So inspecting the first 5 rows of the data frame. So you need to mention the data frame name. So as you can see here, the data frame name in this case is car dataset. So let's mention it car dataset dot yet. So this yet function will print the first 5 rows of our data frame. Okay, so as you can see here, we have the first 5 rows. So in the first column, we have car name, so the brand of the car and the year of that particular model and the selling price. As we are discussing about the used cars, so these are the selling price of various cars and the present price of new car and the kilometers driven by that car, fuel type whether it is petrol, diesel or compressed natural gas, and seller type whether the seller is a dealer or an individual. Then we have the transmission, whether the gear system is manual or automatic, and we have the number of owners before that particular person. Okay, so these are the 9 columns or 9 features we have in this data stream. Okay, now let's see how many total data points we have. Okay, so checking the number of rows and columns. So basically we are just checking the number of data points we have in the entire data set. So mention the data frame name, which is car dataset dot shape. So this shape function will give us the number of rows and columns. So totally we have 301 rows and 9 columns. So we have 9 columns here and totally we have 301 rows. So 301 rows means there are 301 values of different cars. So what we are basically trying to do is we will train our machine learning model with all these selling prices and other features of the car. And once it has learned from this data, when we give new information like the kilometers driven, fuel type, etc., the machine learning model can predict how much price the car can be sold. Okay, so this is what we are going to achieve in this particular case. So as you can see here, it has the year. So if the car is very old, the price will be somewhat less, and if the kilometers driven is very high, then a person won't buy it for a high price, right? So these are several features on which the price depends, right? So now let's inspect more about this data set. So what I'm going to do is get some information about this data set. Getting some information about the data frame or data set. So mention the data frame car dataset dot info. So this will give us some information about the data type, about the objects we have. So as you can see here, we have totally 301 entries. So 0 to 301, and we have totally 9 columns. Okay, so these are the 9 columns we have, and we have 301 non-null values. That means totally we have 301 entries and 301 null values. Sorry, non-null values. That means no values are missing. Okay, so and we also have this data type we have. So it is a 64-bit integer. This is float, and we have this object kind of thing. So these objects are nothing but categorical data. So as you can see here, these are some text data. So these are categories. For example, in the fuel type, the categories are petrol, diesel, and CNG. In the seller type, the categories are dealer and individual. Okay, so and in transmission, it's manual and automatic, such kind of things. Okay, so those are given as object. So now what we will do is, it's again, so there is another function for checking particularly the missing values. So as we have seen here, there are no missing values here, but it is very important function you need to know. So I'll mention it, how you can find the number of missing values. So checking the number of missing values. Okay, so car dataset dot is null dot sum. So this function will tell us how many missing values are there on each column. Okay, so as you can see here, we don't have any missing values. So if we have missing values, there are also some steps that we need to do, like imputation. to replace those missing values with some suitable values. Okay, so totally we have 9 columns and there are no missing values in this particular data set. So it is a very good thing. So we can proceed with further process that we need to do. Now what we shall do is, let's check the number of values for this categorical data. Say for example, in this fuel type we have petrol, diesel and compressed natural gas, right? So we are going to check out of these 301 entries, how many cars are petrol cars, how many cars are diesel cars, etc., and how many cars as a dealer as their seller type, and how many individuals are there. Okay, so those kind of things. So we will be checking that for this fuel type, seller type and transmission. Okay, so transmission will be manual or automatic. So I'll show you how you can do that. So checking the distribution of categorical data. So we are going to see how these categories are distributed in this entire data set. So I'll print this. So print, mention the data frame name, which is car dataset dot. Now you need to mention your column names. So we are going to check this for fuel type, seller type and transmission. So car dataset dot fuel type. So fuel type is one column, so we shouldn't put the parenthesis here. So fuel type dot value counts. So this will count the values for petrol and the number of values for diesel. Okay, so value counts. So this will give us the number of values for petrol and diesel. And let's do the same thing for dataset. Now let's check this for this seller type. Okay, so seller type dot value counts. Okay, now thirdly we are going to do this. Okay, so again, okay, so now let's check the same for the transmission. Our dataset dot transmission dot value counts. So this will tell us the number of values. So let me run this. As you can see here, out of the 301 values, 239 values are of petrol cars and there are 60 diesel cars and only 2 cars are of compressed natural gas type. Okay, and in the case of dealers we have in the case of seller type, so which is the second one here. So in the case of seller type we have dealers, so 195 dealers and 106 individuals. Okay, and in the case of transmission there are totally 261 manual transmission cars and 40 automatic transmission cars. Okay, so it is a very good estimation. So it tells us how our data is estimate, or how our data is distributed in our entire data set. Okay, now let's encode this data. Okay, so as you can see here, the data in this particular columns are in what should I say, they are in text, right? So but our machine learning model cannot understand text properly. So what we are going to do is, we are going to convert this text into some numerical value. So what we are going to do is, so we have this petrol value, right? So wherever there are petrol we will change that to 0, and wherever there is diesel we will change this to 1, and if there is CNG we will change the to 2. So those kind of things. And for dealer we will put a value as 0, and for individual we put the value as 1, and the same for manual and automatic transmission. So this is known as encoding the data. Okay, so if we put those numerical values, it is easy for our machine learning model to understand it. Okay, so because computers better understand numbers rather than text. Okay, so we are going to change these values to appropriate numbers. So this step is called as encoding. So let me put a text here as encoding the categorical data, because these particular columns contains categories. So categorical data. So first let's encode the fuel type column. So encoding fuel type column. Okay, so car dataset, we can use the function replace to replace all the values with suitable values we want. So the column name is nothing but fuel type, right? So mention it here. So you need to mention it inside the codes fuel type. And for fuel type, I want for petrol, I want the value to be 0. Okay. And for diesel, I want the value to be 1. Okay. For diesel, the value should be 1. And for CNG, so you can see the values here. So we have CNG, and for CNG, I need the value to be 2. Okay, so for petrol, all the values of petrol will be transformed to 0. For diesel 1, and CNG it's 2. Okay, so and then you need to mention in place is equal to true. So we want to change them to this value, so we need to mention this in place parameter. Then let's encode the same for the seller type. Okay, so I'll just copy this. So we need to do this for 3 columns. So I'll just paste it here. So first we have did this for fuel type column. Now let's do this for seller type. Okay, so for seller we have dealer and individual, right? Seller, and in the case of seller we have individual and dealer. So if the value is dealer, I want to change it with 0, and for individual I need to change it with 1. Individual. So you can see that we have this individual parameter. Okay, so individual is 1. We can remove this because there is no third category. Okay, so for dealers, all the dealers word will be replaced with 0, and all the individual will be replaced with 1. Okay, so in place is equal to 2. And next is the transmission type. Okay, so encoding transmission column. So transmission column, replace transmission. Okay, so in transmission, let's put 0 for manual transmission and 1 for automatic transmission. So the two values are nothing but manual and automatic. So there is no third value. So I'll just delete this. Okay, so now let's run this and see. So this will successfully encode our data into numerical values. So all this categorical data like petrol, diesel, individual or a dealer will be transformed to respective categories or respective numerical values. So now what I'll do is I'll just again print the first 5 rows of the data set to check whether the encoding has done properly. So mention the data frame, which is car dataset dot yet. Okay, so I'll run this. As you can see here, now we have the values such as 0 and 1. So 0 represents petrol and 1 represents diesel. And in the seller, the 0 represents dealer and 1 represents individual. And transmission also, 0 represents manual and 1 represents automatic. So you can see the previous values here. So all these values will be transformed into their respective numerical labels. Okay, so this is one of the important step in this case of converting this text data into suitable numbers. Okay, so now what we will do is, so as we have discussed before, the next step is splitting our original data set into training data and test data. Okay, so I make a text here as splitting the data into training data and test data. Okay, so let's create two variables, x and y. So in x, I'll store all the features I want. So this selling price becomes our target because we are just going to predict this target, right? So this price, so this becomes our target, and all the other features becomes our data. Okay, so in this data, what we need to do is we need to remove this selling price and store it in y, and all the remaining features will come in this x variable. Okay, so we also need to remove this car name because it cannot be used well for our prediction. So for our prediction, we will be using the year on which it is bought, so the kilometers it has driven, what is the present price of it, fuel type, and those kind of things. Okay, so we need to remove this selling price and car name. Okay, so we will put this selling price in y. So let me show you how you can remove these two columns, that is car name and selling price. Okay, so x is equal to car dataset. So in this car dataset, I want to drop two columns. So these two columns are nothing but car name and we have selling price. So this car name is not useful for our prediction. So I'll remove this, and in axis I need to mention 1. So whenever I am dropping a column, I need to mention the axis value as 1. If I am dropping a row, I need to mention the axis value as 0. Okay. So now I need to store this selling price values in Y. Okay. So Y is equal to car dataset dot, no, sorry, not that, it's car dataset, and you need to mention the column name, which is selling price. So this will load all the values of this dataset except car name and selling price to X, and this particular value, selling price value, will be stored in Y. Okay, so this is in lakhs rupees. Okay, so 3.35 means 3,35,000 Indian rupees. Okay, so 4.75 means 4,75,000 Indian rupees. So such kind of thing. So that is the unit of this price. Okay, now let's run this and let's see by printing it. Okay, so something is wrong here. Selling price not found. Okay, so as you can see here, price should be in P should be in caps here. So I just made a mistake here. So I change this now. So this will successfully separate our data and our target variable. So let me print X and Y for you. So this X contain all the values except the selling price. Okay, so this selling price will be removed from our data and it will be stored in the Y variable. Okay, so I'll print Y now. So we have printed X here. Now let me print Y. So print Y. So this will give us the target variable, which is the price of the cars which we want to analyze. Okay, so now what we need to do is, as we have splitted the data into X and Y, now we need to split the data into training and test data. Okay, let me change this to splitting the data and target. So splitting the data and target. Okay, so here let's split it into splitting training and test data. Okay, so we need to mention 4 variables here. One is X train and X test and Y train and Y test. Okay, so let me explain you what are these 4 variables. Okay, so we have this data and target, which is priced separately, right? So I want to separate this data into training data and test data. So what I'm going to do is I'm going to put all the training data in the variable called as xtrain, and all the testing data will be stored in this xtest, and the labels, or sorry, the price of all the values in xtrain will be stored in ytrain, and all the price values for the xtest will be stored in ytest. Okay, so this xtrain contains the data of training, and the xtest contain the price of the training data, and ytrain contains the training data of all these data, and y test contains the corresponding selling price value. Okay, so now we need to use the train test split function we have imported. So as you can see here, we have this train test split function which we have imported from sklearn.model selection. So I'll call this function train test split, and here we need to mention x and y. Okay, so these x and y are nothing but, so what we have splitted here, so the x represent all the data and y represents the price. Okay, so x and y, so x comma y, and let's say the test size is equal to 0.1. So 0.1 means 10 percentage. So 90 percentage of our data will be training data and 10 percentage of our data will be testing data. Okay, so the data set we have is very small. It has only 301 data points. So I'm just taking 0.1 percentage as test data. So if we have a large data set, we can have 20 percentage of data. Okay, typically in machine learning, we also deal with data sets containing thousands of values, 10,000s of values, or even sometimes lakhs, or those magnitude of values. Okay, so if your data set is large, then your prediction will be better. Okay, so that's one important thing to note here. This is a simple data set. Okay, so hence we are just having zero point 0.1 test size, which is 10 percentage of the original data. And now we need to mention random state. So I'll put random state is equal to 2. Say for example, if you want to split the data in the same way that I have splitted, you need to put the random state as 2. So if you put this random state is equal to 3, your data will be splitted in some other kind. Okay, so the splitting will not be similar to what I am doing. Okay, so if you want to split the data into the same way that I am doing, so you can put this random state. Okay, so this is not that important. So this is basically to reproduce the code. So these are the parameters we have, that x and y, test size and random state. So this will split our data into training data and test data and their respective shelled price values, which will be stored on y train and y test. So let me run this. So we have successfully splitted our training data and test data. Now let's train our model. So this part is called as model training. So first let's use a linear regression model for our predictions. So one is linear regression. Okay, so we need to load our linear regression model. Loading the linear regression model. So if you remember, we have imported our linear regression model from sklearn.linear models, right? So from that I'm importing this linear regression which I'm using here. So let's import it. So let me create the variable as linear regression. So short form as lin.reg. So this is linear regression model. So linear regression model is equal to. So this is how you can load this particular model to a variable. Okay, so here the variable is nothing but lin.reg model. Okay, so let me run this. Now we can fit our data to this linear regression. Okay, so the data here is nothing but the x train and the respective values is nothing but y train. So we need to fit this model with x train and y train. Okay, so lin.reg model dot fit. So this is the important function. So this is used for, so the fit function is used to train our model. So here you need to mention x train and y train. So y train are their respective price values. So let me run this. Okay, so this will train our linear regression model. It will find the equation of that linear regression model. Now let's evaluate our model. So linear regression is just a line. Okay, so the equation is nothing but y is equal to mx plus c. So it is just a normal linear function. Okay, so now let's evaluate our model about its error score. Model evaluation. Okay, so first let's predict using our model on our training data. Prediction on training data. So for that you need to use the function dot predict. So I'll create, or I'll declare the variable as training data prediction, which is equal to lin. So you need to mention the model, which is lin.reg dot model, and here you need to use this predict function. So this will predict the price values based on the other data we are giving. Okay, so let's train. So the model's prediction, or the here the model will predict the price of all the values present in this X train, and it will store all the values to this training data prediction variable. Okay, so I'll run this. So now we need to compare the values predicted by our model with the original values. Here the original values are nothing but Y train, right? So let's compare and see how our model is performing. So for regression, we use various metrics such as R-squared error, mean absolute error, root mean square error, etc. Okay. So in this case, I'll show you how you can use R-squared error. So this R-squared error is one of the important metrics. So R-squared error. Let's create a variable as error score. So error score is equal to. So if you remember, we have imported this metrics function from sklearn. Metrics dot R2 score, and in that we need to compare the original price values, which are y train, and the values predicted by our model. So here you can see this is the original values y train, and the values predicted by our model is stored in training data prediction. Okay, so we need to mention both of them. So it will compare the values predicted by our model and the original values. So y train and training data prediction. Now let's print our error score. So the error score should be as low as possible. R squared error. So here I want to print this. So here I'll mention the error score. Okay, so let's run this. So we got the error score as 0.879. So it is kind of good for our particular case. So there is not a definite value that the R square should have. So we cannot say that if the value of the R square is zero point 0.5, then the model is predicting correct or not. So the value of R squared error depends on each problems we are solving. So it depends on the magnitude of the value we are using. Here the magnitude is in like 4.7 point such kind of things. So it all depends on what particular magnitude we have. Okay, so we cannot just give a generalized value on like the error square can be this value. Say for example, for accuracy score we can tell that if the accuracy score of our model is more than 75 or more than 80, then our model is performing well. But we cannot say the same in the case of R squared error. Okay, so we use accuracy score for classification problem, and in the regression case we use R squared error. So the another important way to understand about the performance our model is to plot the values predicted by our model and plot the values predict plot the values of original prices. Okay, so I'll show you how you can do that. So this will tell us how close the values are. So now we are going to visualize the actual prices and predicted prices. Okay, so these values should be as close as possible. Predicted prices. Okay. So PLT, so PLT is nothing but matplotlib.pyplot. So we have imported it as PLT. So PLT.scatter. So let's plot a scatter plot. So here let's mention y train and training data prediction. Okay. So these are the two values that we want to plot. PLT.x label. So we need to give a x label. Let's have our x label as actual prices. So actual prices are nothing but y train. Sorry, actual price, and we have the y label as plt dot y label. The y label is nothing but the predicted price. Okay, and let's name our plot as plt dot title actual prices versus predicted prices. Now you need to put this plt.show function to plot this graph. So it will print our graph plt.show. So let's run this. So this will tell us how close the values are. As you can see here, there is not much distance between the values here. So most of the values are closer to each other. So once the price value increases, there is some gap because the price of the cars are in the range are within the range 10, right? There are very less values greater than 10. That's why there are very less values in this case. But as you can see here, the values are as close, are very close. So that means the values predicted by our machine learning model is very close to the original sold price. Okay, so this is how you can estimate your model performance by plotting the prediction and the original values in the case of scatter plots. Okay, so now what we will do is let's do the same, but in this case let's evaluate our model in the case of test data. So as I have told you earlier, we will train our machine learning model with training data and test it with test data. Okay, so now let's do that. We just need to do the same thing again. So I'll just copy this part. We just need to put some differences here. So I'll paste it here. So you just need to change this to test data. So previously we have predicted for training data. Now let's predict it for test data. So here the test data will be x test, right? Okay. So it's x test. So totally testing data contains 10 percentage, right? Say for example, in this case we have 301 data points. So 10% of it is 30 values. Okay. So these 30 values will be predicted and it will be plotted in the graph. So that's what we are going to do. And let's also find the R squared error. So I'll run this. So this will predict the price values of all the values in this X test. So R squared error. And in this case, I want to compare with test data prediction and Y test. So remember that we are comparing, sorry, we are working on test data, right? So the values for all the test data, the price values is stored in Y test. Okay, so we need to compare this Y test and test data prediction. Okay, so we are just doing the same thing that we have done here, but we are just changing the training into test. Okay, so I'll run this and see what is the R square value. Okay, it's 0.836. So it is a very good value. So as you know, if your value R square value is less in this case, then the model performance is good. Okay, now let's also plot the graph and see. So this will just plot for those values. Okay, so we just need to make some changes. So here we need to mention Y test and training data prediction. Okay, so let's run this. So this is for test data prediction, right? So as you can see here, here we have just only 30 values. That's why there are not much values here, and they actually lie in the same line, right? So there is not much difference, or there is not much distance between them. So but if you have more values in your training data and test data, then we will get better predictions. Okay, so this is not a bad prediction. So this is kind of good on this 30 data points. Okay, so in this case we have linear regression models, right? So now let's use lasso regression and see how this is performing. So generally lasso regression performs better on most of the cases. So linear regression performs well on those cases which are directly correlated or positively correlated. Say for example, if one value increases, the other value also increases. Then in that case, they are directly proportional, right? The two variables are. In those cases, the linear regression model will perform well. So in other most of the cases where there are multiple features and multiple columns, so in that cases we use other regressions like lasso regression, XGB regression, which is known as XG boost regressor, such kind of things. Now I'll do the same thing with lasso regression. Okay, so I'll create a text here as lasso regression. So previously we have did this with linear regression. Now let's do this with lasso regression. I'll just copy all these things. So you can choose here and just press shift plus down key. So this will copy all the cells. So I want all these cells. We just need to make some changes. So copy cells. Okay. Paste. Control V. Okay, so this will paste all the cells. Now we need to change this model to lasso regression, right? So previously we have worked on linear regression. Now we need to change it to lasso regression. So we have imported lasso regression from sklearn. So it is nothing but lasso. So let's name this model as last reg model. So this represents lasso regression. So I'll change here also last reg model. So I'm fitting the X train and the Y train. So this will train our lasso regression models. So you can see the various parameters here. Okay, so we have this alpha value and other kind of things. So, and then now let's evaluate our model. So in this lean reg, I'll just change to last reg X train. Okay. So this is the R squared value for lasso regression. So for linear regression, it's around 0.87, and for lasso regression, it's 0.84. Okay. So now let's visualize this also. So as you can see here, in the case of linear regression, it is close. but in the case of lasso regression, it's much closer than the values plotted for linear regression. So this is a very good fit for this particular project where we can use lasso regression. Okay, so now let's predict this for test data. So I'll change this to last reg. Let's find the r squared error. So the r squared error is kind of more in this case. So let's print this. So as you can see here, they kind of lie in the same line. Okay, so the distance between 2 points are not much higher. So this is a very good fit for this particular case. Okay, so this is how you can use multiple models for predicting a particular value and compare how well the model is performing. Okay, so you just try to do the same with other models like XGB regressor and other regression models and see what kinds of plots you are getting. Okay, so this is how you can find the price of used cars using this particular data set using linear regression and lasso regression models. Okay, so do practice these codes. So let me just give you a quick recap. So first we have imported the dependencies. We have imported pandas for building the data frame, and we have this matplotlib library and cbon for making the plots that we need at in the end of this project, where we have plotted the predictions of our model and the original data points values. And then we have imported this train test split function to split our data into training data and test data. And we have imported this linear regression model and lasso regression model and metrics for evaluating our model. So we have loaded our CSV file into our pandas data frame using this read CSV function. Then we have printed the first 5 rows of our data frame, and we have seen what are the various columns we have. So totally we have 9 columns, and we found that there are totally 301 rows and 9 columns using this shape function. And we have find the information of this dataset using dataframe.info. So we see that there are no missing values, so which is a good thing. So then we have seen how many values are distributed. So how many petrol values are there, how many diesel values are there, and the same for seller type and the transmission system, etc. So then we have replaced all these text data to suitable labels or suitable numerical values. Okay, so once we have encoded our data, we have seen that it has encoded it well. So then we have splitted our data and target separately. So here the target is nothing but the selling price. Okay, so this selling price is in the unit of this price is in lakhs. Okay, so Indian rupees. And then we have printed it. So then we have splitted our data into training data and test data. So our model will be trained on our training data and evaluated on our test data. Okay, so first we have seen using linear regression. Okay, so we have evaluated our model, find the r squared error value. Then we have plotted our predictions made by the model and the original values, and then we have did the same for test data. Okay, so and finally we have also used a lasso regression model to do the same, where we have also predicted for training data and test data, and we have plotted the prediction. Okay, so I hope you have understood all the things we have covered in this video. So you can also find the link for this collab file in the description of this video. So just let me know if you run into some error. Okay, so thanks for watching.